something is seriously wrong with the Antarctic Ocean, because down there, evolution has gone completely off the rails. Sea spiders grow wider than a pizza, starfish sprout 50 arms, and snatch fish straight out of the water. A single jellyfish stretches longer than a blue whale, and in the black water below, a squid the size of a small car is drifting around with eyes bigger than your face. Every one of these animals is supposed to be tiny. In any other ocean, they'd fit in your palm. But down here, the rules are different, and the reason why is genuinely insane. And yeah, all of these things are real. Welcome to polar gigantism, the weirdest loophole in biology, where the coldest water on the planet takes normal animals and turns them into straight-up monsters. Most people have never even heard of it, and you'd think in a place where everything's frozen and food is scarce, animals would get smaller to save energy, right? Nope. The exact opposite happens. Antarctic creatures get supersized. Small things become big, and big things become massive. But to understand why, we first need to talk about something most videos totally skip: why the Antarctic Ocean is even allowed to have giants in the first place. See, the Antarctic isn't just cold, it's isolated, like aggressively, weirdly isolated, as if the planet deliberately walled it off from everything else. About 34 million years ago, South America and Australia finished drifting away from Antarctica, and a new current was born. It's called the Antarctic Circumpolar Current, and it's the strongest ocean current on Earth. It circles the entire continent like a freezing moat thousands of kilometers wide, and it doesn't let much through. Warm water from the tropics hits this current and gets bounced right back. Species trying to migrate south hit a temperature wall they physically can't cross. So for roughly 30 million years, the animals trapped inside this ring have been evolving in their own private laboratory, basically cut off from the rest of the ocean. Now think about what that actually means. Normally, fast-moving predators keep everything else in check. Sharks, barracudas, reef fish. They force prey animals to stay small, quick, and alert. If you're slow, you get eaten. If you're fat, you get eaten. If you're weird-looking, you definitely get eaten. But inside the Antarctic ring, most of those predators never made it in. A whole rulebook just got deleted. And without those rules, really strange things became possible. Animals that would have been shark food anywhere else could suddenly afford to grow slowly, get massive. Trade speed for pure size. Imagine being locked in a room for 30 million years with plenty of food and no bullies. Yeah, you'd probably get weird too. So that's the stage. Now let's meet the animal that took this loophole and absolutely ran with it. Mesonychoteuthis hamiltoni, or the colossal squid. Most people just lump this thing in with the giant squid and move on. They hear squid, think big, done. But the colossal squid isn't a bigger giant squid. It's a completely different animal. And its origin story is borderline absurd, because the colossal squid comes from a family called glass squids. And glass squids are these tiny, fragile, translucent little things that float around looking like see-through gummy bears with eyeballs. Most are only a few centimeters long, delicate, transparent, basically harmless. They look like jewelry. So how do you get from a family of glass jewelry squids to a 500-kilogram tank with hooks for hands? And speaking of, let's talk about its eyes for a second. A colossal squid's eyes are roughly 27 centimeters across, about the size of a dinner plate, bigger than a blue whale's eyes, bigger than a T-Rex's eyes, bigger than any eye on any animal at any point in the entire history of Earth. And they're tuned for exactly one job: picking up the faintest flickers of bioluminescence from prey 2,000 meters down in total darkness, because that's where this thing hunts. And it doesn't hunt gently. Forget the suckers you saw on your calamari. A colossal squid has rotating, razor-sharp hooks on its tentacles. Picture a kraken that grew bear claws at the ends of its arms. That is what's currently patrolling the water below Antarctica right now while you watch this video. But even this thing isn't the king down there, because it has one serious predator, the sperm whale. Sperm whales dive over a kilometer straight down specifically to hunt colossal squid. And the evidence is everywhere. Whales surface with basketball-sized sucker scars on their heads, They have thousands of indigestible squid beaks sitting in their stomachs. If there's a real-life kraken battle happening on planet Earth right now, it's happening in the water below Antarctica, and humans have basically never seen one. Here's how rare these things are. The first fully intact colossal squid ever recovered came up in the nets of a New Zealand fishing boat in 2007. Scientists had to literally thaw it in a freezer for days just to study it without ripping it apart. That's how deep and remote this animal lives. And here's the last twist. The colossal squid isn't technically the longest squid. The giant squid beats it by a few meters. But the colossal squid is roughly twice as heavy. It's a brick of muscle, a living tank, built specifically for the coldest, darkest ocean on the planet. So, how does cold water actually do this to an animal? What's the real mechanism? Because once you understand it, every ocean on Earth is going to look different to you. Okay, here's the rule that basically explains every Antarctic giant. Cold water holds way more oxygen than warm water. Not a little more, a lot more. Antarctic seawater holds roughly double the dissolved oxygen of tropical water. For us, that doesn't really mean anything. We breathe air. But for cold-blooded animals, the ones that pull oxygen directly out of the water through gills or skin, or in some cases their actual legs, this changes everything. Every cell needs oxygen. The bigger your body, the more cells you have, and the more oxygen those cells are demanding every single second. In tropical water, there's a hard ceiling on how big a cold-blooded animal can get. Past a certain size, the water just can't deliver oxygen fast enough, and the animal suffocates from the inside out. That's the invisible wall keeping tropical invertebrates small. In Antarctic water, that wall is gone. Unlimited oxygen. You can grow bigger and bigger and bigger, but oxygen is only half the story. The other half is metabolism. In cold water, everything slows down. Chemical reactions inside the body run at a fraction of their normal speed. A tropical fish burns through energy fast, eat, digest, grow, repeat. An Antarctic fish, at near freezing temperatures, its metabolism might run 2, 3, even 4 times slower. It needs way less food per pound of body. And that flips the entire logic of size on its head. In warm water, being big is expensive. You have to eat constantly. In cold water, being big is actually efficient. A bigger body loses heat slower, stores more reserves, survives famine better. Every extra pound becomes an advantage instead of a cost. Now put those two together. Unlimited oxygen on one side, ultra-slow metabolism on the other. That's the recipe. Grow big, slow down, live long, eat rarely. Just exist, but at maximum size. And there's one more piece. Stability. The Antarctic Ocean is shockingly, almost eerily stable. Temperature barely changes. Pressure is constant. There are no hurricanes down there. No heat waves. No violent seasonal swings. And for an animal that grows slowly and lives for decades, stability is everything. You can afford to invest in being enormous because the environment isn't going to suddenly blindside you with something that kills you. Compare that to a tropical reef where temperature and predators and food are all swinging wildly week to week. In that chaos, small and fast and adaptable wins. But in the frozen vault at the bottom of the world, slow and gigantic wins. Every time. That's the formula. Cold plus oxygen plus stability plus isolation plus time. No single ingredient makes a giant on its own. But combine all 5, let it cook for 30 million years, and you get the Antarctic, where basically every invertebrate decides to go absolutely enormous. And once you actually see what's down there, the size of some of this stuff is honestly hard to believe. Let's start with something you already met, the sea spider. In a tropical reef, this thing is the size of your fingernail, barely noticeable, easy to miss. In the Antarctic, it grows over 2 feet across. Same family, same body plan, just 20 times bigger, and their anatomy is wild. Sea spiders don't have lungs, they don't have gills. They absorb oxygen directly through their legs. That's actually why the legs are so absurdly long in cold water. They need that surface area to pull in enough oxygen for a body this size. And get this, their legs do most of the work, including digestion. Their guts literally extend out into their legs. They're basically walking stomachs on stilts. They hunt with this thing called a proboscis. Picture a fleshy straw with a mouth on the end. They creep across the seafloor on those long, pale legs, jab the proboscis into a starfish or a sponge, and drink it from the inside out. A spider-shaped milkshake machine, crawling through the dark. Speaking of starfish, the Antarctic has starfish that look like the universe glitched. Labidiaster annulatus, the Antarctic sunstar, can have over 50 arms. And unlike normal starfish that slowly crawl over clams, this one holds its arms up like a forest of fingers and literally snatches passing fish right out of the water. It's an active predator. Evolution took a peaceful little starfish and turned it into an 8-foot sea floor trap. Then there's the lion's mane jellyfish. This one technically holds the record for the longest animal ever measured. A specimen washed up on a Massachusetts beach back in 1870 with tentacles reportedly over 37 meters long. That's more than 120 feet. Longer than a blue whale. Longer than a basketball court. And yeah, lions' manes live in the cold north too. But the principle's identical. Colder water, more oxygen, and suddenly this fragile floating thing can stretch to ridiculous lengths. Now here's one most people have never heard of. The giant Antarctic isopod. Glyptonotus antarcticus. You know those tiny roly-poly bugs you used to poke in your backyard? Imagine one the size of a loaf of bread. That's what's crawling around down there, eating basically anything it can find. Sponges, worms, dead fish, occasionally each other. A loaf of bread with legs and antennae, or the Antarctic ribbon worm. A single Nemertean worm can stretch over 100 feet when fully extended. It just sits there coiled on the seafloor, waiting. When a small animal wanders by, it fires out a long, sticky proboscis that grabs the prey and yanks it in. Imagine a frog tongue, but on a living cable of flesh, 100 feet long, hiding under the ice. And maybe the weirdest of all, glass sponges. These aren't animals that hunt or move. They're filter feeders, shaped like these intricate lattice towers made out of literal silica, glass. And some glass sponges in the Antarctic are estimated to be over 10,000 years old. There are animals alive under the Antarctic ice right now that were already thousands of years old. And finally, we gotta mention krill, because krill are small, only about 6 centimeters long, so they don't fit the pattern, right? Wrong. Antarctic krill make up the largest single-species animal biomass on Earth. Their combined weight is estimated at around 400 million metric tons. That's more than every human on the planet put together. It's not individual gigantism, it's collective gigantism. The Antarctic didn't just supersize its creatures, it supersized an entire species in sheer numbers. Either way, the result is the same. Bigger than anything else. Now, every single animal I just listed, cold-blooded. Which brings up the obvious question. What about the warm-blooded ones? Penguins, seals, orcas, polar bears, all big animals, all living in cold places. Shouldn't they count as polar gigantism too? They don't. And the reason actually reveals something important about how this whole thing works. Real polar gigantism, the kind that gives you colossal squids and dinner plate sea spiders, is strictly a cold-blooded phenomenon. It only works for animals that let the ocean control their body temperature and pull oxygen straight out of the water. For them, cold is a gift. More oxygen, slower metabolism, no energy wasted generating body heat. Warm-blooded animals have the exact opposite problem. They have to burn fuel constantly just to stay warm. Every extra pound means more calories needed, which means more hunting, more risk. And in the Antarctic, food is already scarce and seasonal. The math just doesn't add up for cartoon-level size. But warm-blooded polar animals are still noticeably bigger than their warm climate cousins. That's because of a totally different rule called Bergmann's rule, which says that in colder climates, warm-blooded animals trend larger because bigger bodies lose heat slower. A bigger seal stays warm longer. A bigger penguin conserves heat better. It's a heat retention strategy, not an oxygen strategy, and it has a hard ceiling. You can't grow bigger than the food supply supports. That's why a polar bear caps out around 700 kilograms, while a colossal squid hits nearly 500. The polar bear is limited by metabolism. The squid is freed by it. And That freedom does something genuinely strange to time itself. In the Antarctic, life moves in slow motion, and I mean that literally. Metabolism is so slow down there that animals develop slowly, reproduce slowly, and die slowly. An Antarctic starfish can live 40 years. A tropical starfish? Closer to 5. A glass sponge, like we just saw, outlives entire human civilizations. And here's the knock-on effect almost nobody talks about. When everything runs this slowly, evolution itself slows down. Generations turn over less often. Mutations accumulate more gradually. Natural selection has way less material to work with each century. So species just stop changing much. They settle in. That's why the Antarctic is packed with what scientists call living fossils. Animals whose body plans are nearly identical to ancestors from tens of millions of years ago. Some sea spiders, sea urchins, and shellfish have barely changed since the time of the dinosaurs. You're not just looking at weird animals down there, you're looking at living museum exhibits. Creatures that pressed pause a long time ago and never really came back. And the weirdest example? Icefish. Icefish live in water so cold that normal fish blood would freeze solid inside their veins. So how do they survive? They evolved antifreeze proteins. Literal antifreeze. Glycoproteins that bind to tiny ice crystals in their bloodstream and stop those crystals from growing any bigger. Their blood refuses to freeze. And that's not even the weirdest part. Icefish also ditched almost all their hemoglobin. Their blood runs clear, colorless. They absorb oxygen straight through their skin and pump it around the body in what basically looks like water, with a few cells floating in it. In any normal ocean, that would be a death sentence. But in water this cold and this oxygen-rich, they don't need red blood cells anymore. They took an evolutionary shortcut that no other vertebrate on Earth has ever taken. Clear blood, antifreeze veins. Ice adapted. Icefish might literally be the most alien vertebrates on the planet, but stability is a double-edged sword. Because when things finally do start to change, there's nowhere for the giants to run. Here's the sad irony baked into all of this. Everything that makes the Antarctic giants possible is exactly what makes them incredibly fragile. Their whole existence depends on water that stays freezing, oxygen-rich, and stable. Take any one of those away, and the whole system starts falling apart. Warmer water holds less oxygen. Faster metabolism demands more energy. And slow-growing, long-lived, cold-adapted animals can't evolve fast enough to keep up when conditions shift quickly. The exact traits that made them thrive become the traits that kill them. And this isn't hypothetical. It's happening right now. Studies on sea spiders have shown that in parts of the Antarctic, where water's warmed even slightly, their maximum body sizes are already shrinking. The invisible oxygen ceiling is pressing down on them. Colossal squid are harder to track directly, but scientists are seeing the same warning signs across other cold water species: changing ranges, shrinking sizes, disrupted reproduction. And the Antarctic Ocean is warming faster than most of the rest of the planet. Sea ice is retreating, ocean chemistry is shifting, and the narrow environmental window these giants have thrived in for 30 million years, it's starting to close. Here's something that'll actually mess with your head. If you took a colossal squid and dropped it into a tropical ocean, it wouldn't just be uncomfortable. It would die within hours, suffocate, cook. Its entire biology is locked into one very specific set of conditions. It can't migrate. It can't adapt fast enough. It's built to be perfect for exactly one place on Earth, and that place is disappearing. And for what it's worth, none of these animals actually pose any danger to us. 0 people have ever been attacked by a colossal squid. No swimmer has ever been pulled under by a lion's mane. Sea spiders are never going to crawl into your tent. The monsters of the Antarctic deep are, in every practical sense, completely harmless. They're just incredible, strange, ancient, enormous, and totally unique to one specific corner of Earth. Maybe the weirdest thing about polar gigantism is how we even found out about it. For most of human history, we had no idea any of this existed. The giants were hiding under a continent of ice, in water nobody could reach, writing their evolutionary novel in total silence. We only started reading the first pages a few decades ago. Freeze an ocean, and life doesn't die. It gets huge, strange, and ancient. And if we're not careful, we're going to lose these living giants before most people even realize they were here. So here's my question for you. If you had to come face to face with one of these Antarctic monsters, which one are you choosing? Drop it in the comments, smash that like button, and subscribe for more.